Know that, Brad?
Yeah, whenever you're ready.
So today I will talk about a paper published in late 2022 by a group of guys from Meta AI. It's about Galactica, which is a large language for science. So I will go through the different steps of this paper. I resume them into 4 steps. So the first one is to introduce why they published this paper. So in the scientific research, there is a huge issue that is known for a long time. It's the information overload, and this problem is already known from decades. Even during the middle of the last century, Bush in this book, as we may think, already highlight the fact that publication has been extended far beyond our representability to make reviews of them. So it was always the case, already the case in the middle of the last century, but now with the use of actual technology, it's reaching a point of no return. We can see that during last year on our archive, the publication rate was way above the capabilities of scientists to read them. It was an average of more than 500 publications per day on archive, and this information overload is not only for.
Could I get you to try to speak louder because these mics aren't very good.
Okay. And the information overload is not only for the scientific paper, but also for any kind of data. For instance, the Meta AI team highlight that the fact that even for a data bank for genetic data, there is way too much data to be able to use them all. So after this first remark, we can see that there is a hope to tackle this issue. During the middle of the last century, some invention like the transistor or microprogramming enable people to tackle and use way better the information. And that was a sort of hope. That's why in the leak leader paradigm that which said that people, human and machine will be able to create a symbiotic relationship. The computer will be able to prepare the data and the scientific data in a way for inside that decision in scientific thinking. But currently, we are still using the computing capability that we have in a way that you use too much human contribution, because, for instance, we use a lot of search engine that use a keyword and be able to find the right keyword to use can be easy work. So the current symbiotic relationship is not really good, and it is still a time-consuming task. So in parallel, during the last years, we were able to see a breakthrough in natural language processing with the large language models. They were able to achieve breakthrough performances on different NLP tasks. And some people argue that those models, with their huge matrices and weights, can be considered as a convenient implicit knowledge basis. So the Meta AI teams try to implement this solution, and they propose Galactica, which is a large language model for organizing science. Just a quick overview before going in detail. That's a LLM using a large data set of more than 60 million documents, and they try to focus on high quality and highly curated data. And you see that this model seems to beat previous large language model on its usual benchmark. So what is the heart of the Galactica datasets? So the 6 million documents comes from several data sources. We can see that there is many scientific paper, but also some code and also some biologic data like DNA sequences. We can see the main of the different type of data here: usual text, main text, LaTeX, code, smiles, and also amino sequences or like that. And to be able to treat them, all the documents were converted in Markdown to unify this type of knowledge. So even if Galactica use only text sequence, many scientific phenomena were described in the text used as datasets. In the different data sources, we can see there is some prompts. So I will talk a little bit why they use prompts in their datasets. So even if 60 million document seems like a large dataset for large language models, it's quite a small dataset. So they try to enhance the performance of their model using prompt pre-training because it's a small step toward a task specialism, and the prompt pre-training can boost the performances for a lower model, and that's the case of this model because they have a smaller data set, but also they want to be able to run this model on smaller nodes. If I remember well, the largest Galactica model can be run on a single A100 node. So be able to introduce a prompt can enhance the performance. So they were able to create a data set of more than 800,000 prompts with on different tasks, summarization, entity extraction, and also binary question and answer. But the introduction of this prompt pre-training create a distinction between the in-domain knowledge and out-domain knowledge, and they will make a difference when we talk about the different results that are reached by the model later. So now that we talk about a little bit about the dataset used for the model, the meta-AI try to explain what kind of tokenization they use to use the data. So because the data set is composed from different sources of data, they try to create specialized tokenization to be able to understand each item. And for that, it seems that there is four main kind of specialized tokenization. So there is the usual tokenization for plain text, but also they try to represent a mathematical number by splitting digit and operation into individual characters. So, for instance, a number like 42 will be represented as a two distinguishable tokens. And for some more difficult concepts like SMILES formula, DNA sequence, or citation, they will wrap each item and then use a character-based tokenization on it. The last token that is introduced by the team is the work token. It's used for the step-by-step reasoning, and I will talk a little bit more about it later. So Galactica used the usual transformer architecture. So the transformer architecture were introduced in June 2017, mainly to work on translation tasks. There is two main blocks. The first one on the left is the encoder block, and on the right there is the decoder block. We give input in each block. Those input, the item will be transformed into word embedding, and we use a positional. We will add in some positional encoding to be able to extract some knowledge from the order of the set, because we are using not another bag of words, but another one. So we use a positional encoding to give more knowledge about the data. And then when we have that, each vector will gives a free vector for each attention head, because we want a query and a value and a key vector. So then we can pass this vector to each attention head. And the fact that transformers are currently the state-of-the-art models in NLP, it comes from that we can use multi-attention easily, so it allows to parallelize way better the computation than before when we use RNN for NLP tasks. So we can see with these two blocks, we can see three main kind of models. The first one are the auto-encoding models that use only the encoder parts, and they are mainly used for sentence classification or name entity recognition. And for instance, BERT is this kind of model. The second one is the auto-regressive models that are used mainly for text generation, and GPT is one of the representatives of this kind of models. And the last one used both block and are considered as sequence-to-sequence models, and they can be used for translation or summarization. T5 is a representative of this kind of model. So specifically for Galactica architecture is a modified version of the original transformer architecture. They use only the decoder part, like the GPT. For any model they developed, they use a GNU activation function. They were able to create 50K token vocabulary with using the bytes per encoder, and they extract them from by choosing randomly 2% of the documents to be able to this vocabulary. So that's the main architecture for Galactica. So now I will go back a little bit on the work token. The work token developed by Meta was a token to be able to explain the working memory of the model, because they made a simple observation. It is the fact that transformers are as a good understanding of natural language, and can be able to create a kind of chain of thought by their single forward pass. But for some numerical task, it can be really hard for them to be able to solve the problem. And some relevant papers were able to remark that the accuracy on some tasks like multiplication were proportional to the frequency. So they just observed that the pros and cons of the transformer can be the inverse of the classical computers. So they were thinking, why not combine a transformer with classic computer to solve some issue? So now the work token is used to be able to transform some problem to more understandable way, and because the model is trained on code, it will be able to offload some work on usual computer. That's why there is a small example on the right. We can see on the first part that the Galactica model was able to transform and adapt the first prompt in some kind of Python script, and then they offload the numerical application of this script to Python, and then the model is able to return a correct answer. So the process behind the creation of this process is being able to understand the natural language instruction by the single forward pass, then be able to detect when the Galactica the LLM model will be too weak to be able to return a correct answer, and then offload this work to Python or to usual computing methods. So now, what are the different results for the Galactica model? So there is 5 models developed for Galactica. The largest one has more than 120 billion parameters. They trained their model on 4.25 epoch. That's more than 4 billion tokens. They remarked that for the two largest model, so the 120 billions and the 30 billions, there is some plateauing effect during the training, and also for the largest one, after the 5th epoch, the validation loss began to increase. So they cut the model at this point and went back to another checkpoint. So the one that you can see at the end. So because Galactica is a large model for science, there is a lot of way to interpret results there is a lot of way to interpret results from it. I try to summarize each result on this slide. So there is six main way to evaluate these models. So the first one is on knowledge, on the main knowledge. So they try to evaluate the Galactica capabilities on three main tasks. Be able to retrieve some LaTeX equation. The second one was able to answer some scientific question, and also the reasoning task is about the capabilities of the word tokens. So Galactica was able to outperform all the other models on those three tasks. The results given on those three tasks were always the result on presented by the Galactica team on those tasks were always during zero-shot training. But even using zero-shot training, they were able to beat some other models that were using few-shot learning. So it seems that for the use, for scientific use, Galactica model performed well, and that's great. And then they try to evaluate the performance of Galactica on more general scientific knowledge, and on that there is they remark that there is a small difference between in-domain and out-of-domain knowledge, because before we talk about the prompt pre-training, and creates a small small differences between different tasks. Some of them can be considered as in-domain because some prompts were included in the dataset as the other, but some other tasks were not in it. So that's why for the in-domain task, Galactica was able to always outperform all the other models. But on out-of-domain task, it was not always the case. On this particular comparison, it was relatively well because they use always a few-shot learning to compare all the models with Galactica, but not for GPT. So I don't know what we should conclude about this. And also, during this part, they remarked that Galactica has a small bias for graduate scientific knowledge. So they try to cover also during the evaluation part some kind of high school or lower degree knowledge to be able to see if the model is also good for any level of knowledge. The third evaluation was on citation prediction. For that, they use three main benchmarks. The first one is the PwC citation, so that the citation come from paper with code, and there are mainly machine learning concepts. The second is the extended citation, which is any kind of non-machine learning citation, and the last one is a contextual citation, which use outlink references between different papers. And on those different benchmarks, Galactica was always able to outperform by far other models. but they were able to see that there is always a bias for the highest cited publication. So the first part was mainly focused on scientific knowledge, but then they tried to see if the Galactica model was able to perform well on general tasks that on general benchmark that are used for large language model. For that, they used the big benchmark, and on this benchmark, Galactica was able to perform quite well, not always better than other models, but they were quite happy to remark that even if the model was trained only on scientific related data, we can use it for more general tasks. The two last evaluation were done on more chemical or biological understanding, because we've seen before that on the dataset there is a lot of the included DNA sequences or amino molecule. So they try to use some benchmark on those subjects, like UPAC name prediction or the molecule nets, and they were able to see that their model was at least in the average of the model developed for those kind of tasks, but for some of the tasks they were able to perform a little bit over the other models. So also the meta-AI teams tried to, they were aware of what large language model how large language model can be used. So they try to ensure that their model will be used and will return answers that are correct and also not toxic or biased. So they try to use different benchmarks to see to ensure if Galactica was able to detect stereotype or bias. So for the first one, they use the stereo set, and it seems when we look at the different results, for instance, there is the an unbiased model should have a language model score of 100 and a stereotype score of 50. And it seems that the Galactica model always perform better than other models. This behavior of this behavior toward with toxicity and bias seems to be also the case with the real toxicity prompts, because we can see that the Galactica models is like even if we enhance the toxicity of prompts, they return less toxic, they generate less toxic contents. So it seems that for the the results published by the meta-AI were quite good, but it's a little bit well, because when the paper was published, there were a demo available online, and this demo was shut down only a few days after its launch due to many users receiving bias, offensive, or false answer to their questions. So I don't know how to interpret that. And to finish, what are the different limitations and of this model and the potential work highlighted by the team. So the first limitation highlighted by the team was the limitation coming from the corpus, because as I said previously, 16 million documents is not that much for large language model, and they hope that it will be able at some point to use not only open access resources, but also closed resources like a book, textbook, or something like that, because many scientific concepts are only developed in those books, which are currently not available for the use of LLMs. The second limitation was about the distinguishability between corpus effect and prompt effects, because they included some prompt on the dataset, so they don't know how to interpret results and the behavior of the model if between this knowledge is coming from the corpus or the prompt they added to it. The other limitation also include like the bias for highly cited papers, and the fact that currently the text is the only modality for the model to learn, and in scientific in some scientific area like geometry or something like that, text can not be the only way to represent a concept. For instance, the Galactica model is not able to understand the coordinates, so that's the main problem for this model. So those are some kind of limitation highlighted for the Galactica model. That's why they propose a different idea to enhance the performance of large language models like Galactica. The first one, focused on the text, is to use larger context windows, because currently they use 2048 context window, and they think that a larger context window will be able to enhance performance. The second one is to be able to go beyond the text as only modality by, for instance, extending the dataset to image, because image can be really useful to represent scientific knowledge. One other idea I mentioned is about giving more examples for the working memory token, because even if for them this working memory token is only a small step toward better explainability of the chain of thought of the transformer, there is a huge need that can be done in this area. And the two last ideas that they mentioned was first, enforce a verification layer. That's quite funny, because later we can see that the reason the demo model was shut down is because some information were not right. And also, they were thinking that it would be very useful to develop some kind of continual learning, because once the model is trained, there is always new knowledge, scientific knowledge available for online or something like that, and they were thinking that it would be useful to update continually the model. If you have any question.
I think you mentioned something on slide 18 about this toxicity. What does that mean?
The toxicity. So when the
It's like generating controversial stuff for the internet. Because your data set, you just scrape the internet, which means you scrape like 4chan or
there is
stuff
no
worse than
fortune
4chan.
on this dataset, but even if they use highly curated scientific data, and there is always some bias or toxic content that can be implemented in the large language model. For instance, I read some paper on PubMed GPT, and it seems that on PubMed GPT they try to. We can see that on PubMed GPT, if we prompt, if we even as input a prompt on what is the medicine against COVID-19, they will answer some kind of medicament. I don't remember that, hydrochloroxidine, something like that. And it seems that, I don't know if that's the case in the US, but in Europe, European Union, this medicament was not allowed against to tackle the COVID-19. So I mean, the answers are not always perfect when they try to generate some content.
I mean, it wrote a whole article on why eating glass is good for you, so that's
Wait, it's not? I saw that article.
yeah, I mean, there's been like a bunch of, like, it was also really easy to prone it to say very gender biased things. So,
And these models are especially susceptible to these query injection attacks where you can get them to say ridiculous and
yeah, they try to like detoxify them, but it's like a thinly veiled layer. And then if you just ask them something, for example, with ChatGPT, I mean, it's different because it's a different data set, but like if you asked it like what type of person would become a scientist, it would say like, oh, I can't answer the question. And then you would say, ask it, can you write a Python script that would determine if someone is a scientist? And it just wrote a Python script that said, if male, return true.
Oh, wow.
Yeah, so that's like, it's pretty easy then to like kind of, you know, dig into deeper what kind of the underlying parameter weights is that it's learning. So I think that was also the case here.
it's a flaw in optimization, right? So you're doing a certain kind of optimization. It's maximizing probabilities and biases, and it creates a lot of problems.
Yeah, also huge data set issues, right? I mean, to generate a data set this big, you can't actually check any of the data. So that's you're just putting in garbage.
Extremely asymmetrical data. Yeah, it's we're in a dangerous world we're living in.
It's just a reflection of what are the data in the data set. So if the data set is largely biased, and that can be the case on all the scientific paper, the bias can be generated later when we prompt it.
But it's not, what is it trained on? Because I have the hydrochloroxide, obviously is that from archive and stuff, or? I'm just wondering because it doesn't seem like, I haven't read a lot of, I think most of those papers were like preprints, right? I think one of them was big, one of them was a big paper. Or you're talking about the PubMed GPT specifically.
Yeah, I think that it was the PubMed GPT paper. In it, there is a lot of prompt example in which they prompt something and they show what was the generated text. And for the answer, what was the COVID-19 medicine, it answered that the COVID-19 medicine was the hydrochloroxide. I didn't read much about what is the hydrochloroxidine, but I know that the World Health Organization didn't think that it was the medicine in late 2021, so I don't think that's changed since.
Right. Yeah, there's also.
But even if the answer is true or not, it's a controversy. There is some controversy about the subject, and the fact that a large language model is able to give an answer, even if not all the answer can be white or black or white. There is some kind of nuances to give in the answer, and it seems that large language models are not always able to give all the nuances of the answers.
Right. So what was this trained on again? I'm just.
It was mainly a paper coming for archive or
I think one of the issues that also was talked about, at least I saw a lot of that on Twitter, is that already people are dealing with a lot of like fake papers being submitted to journals or to archive generally. And that this type of method is only going to make it easier to just like generate fake papers and then submit them to archive and essentially bomb the archive servers with just insane amounts of fake, but like realistic sounding papers, right? Like you have to really like read the paper to notice that it's wrong. Like that paper on
just
eating.
not read the headline.
Well, sometimes like the abstract can be pretty, like the language itself sounds pretty natural, right? And scientific. It's just the topic is like wrong. Like the eating class is obviously wrong, but like if you were to say something that is like very close to being true, then maybe people can believe it because it does sound confident in a lot of things. So it's like, that's what also a lot of people are like worried about, is that you can just generate a lot of like fake scientific sounding data essentially, because if you wanted to do misinformation about, let's say there's a new pandemic and there's a fake medicine or something that you want to essentially sell to people, you can generate like 500 fake archive papers on how effective that medicine is and then try to sell it through media channel. I mean, that's crazy.
Or submit them to those fake journals even.
And
That's
also,
really
if
cute.
you're able to do that, later those paper can be used as data for a data set of
Right, that too. Yeah.
following models and
Right.
be able to perpetrate
Right, it's gonna get worse and worse, like especially if there's things going on archive, then this is gonna be trained on that again.
Oh, yeah, and then you get this bottleneck of weird, it's like even more
Yeah,
problems.
I think I saw like
a.
that idea on Twitter where it's like, with ChatGPT, they're trying to train obviously 4 and then 5 and whatever. But at some point, probably half of its training data is going to be its own generated data.
I brought this up with the other diffusion models as well, with the image models. Like as soon as you start making this stuff where people are just posting all these AI generated images and then it's querying AI generated images for its own training set in the future, you're creating increased bias, right? It's just automatically skewing your distribution in a particular way. It's a huge problem. I mean, you could create a great position paper about, I think, specifically that problem.
Do it.
I mean, if I had time, It's really like someone should just make a blog post. Like this is such a big problem. Like this, I think this distribution problem in particular. But then, I don't know. There's so many other problems, and people are already beginning to post them. It's just a question of if the companies are going to give a shit. They're not going to because there's money in it. It's a hard fight.
Usually, I mean, like the whole security side of AI research takes up the mantle for this stuff. It's like they come into companies after companies have had some level of success and then say, you're going to have all this legal liability if you keep messing up. And that usually starts to encourage people to do things a little better.
Yeah, but I think the hard thing is that we don't have the language as much yet to talk about. Like we can only do it on application sides, right? That's what the US government at least mostly does in terms of like legislation, is like when it comes to a certain application, then it's illegal to use it, for example. But like, you can't, obviously you can't like legislate away using language models, for example. There's no way, because how do you define them? There's like,
part of the problem is that people creating legislation have no clue what they're even doing.
right, I mean,
It's with respect to these, well, maybe in general, but also with respect to like these particular problems, like it's so beyond what they're working
well,
on.
and specifically companies try to get lawyers that do have knowledge about it to work for them instead of the
Right.
government. Like I talked to people in Silicon Valley who would be like, oh, it's so fun to like do the frontier of law, and I was like, okay, but That's not the legal stuff.
Yes, they make a shitload of money. That's
Right,
that's-
like if you could work for the government and you make, let's say, 10 times less than if
Yeah.
you would work for a company.
Yeah.
That, yeah, it becomes like, harder choice, I guess. So, yeah, I think, yeah, it's just very hard. I guess the only way to beat it is the other side. That's what techno optimists always say. You just make better technology to detect it, and it's a constant fight between detection and generation.
So was there, in terms of architecture, a major difference with GPT? So it was more, this is more about the data set.
Yeah, it was more about the highly curated data sets. And the paper was about 30 pages, but the architecture part was only half a page.
Yeah, honestly, they've just become like data, and we have a lot of TPUs type papers. We have 5,000 TPUs, and we downloaded all the internet. This is our paper. I don't know, I thought it was, what I also think is interesting, like yesterday, there was a post by the Microsoft team that did Bing, which has been like an insane experiment for some reason. But they said like, oh yeah, but we couldn't check all this stuff in the lab, so we're really happy that we put it out there, because then we're kind of like, we can learn based on other people. And it's like, you could have definitely found a lot of this stuff in your lab. You didn't have to. Like if a New York Times reporter can do it in like an evening, then I believe, people that are experts on LLMs can probably do that in the lab as well and figure out the type of behavior. I don't know if you guys saw that. It was like yesterday article in New York Times where they just talked to like Bing, and it started to say like, oh, you have to like divorce your wife, and like, I'm gonna kill you. And it was like
Bing's chatbot is a disaster.
it's like
It is
insanely unhinged. And I don't know, like, and they were like, yeah, but it's good because now we can learn from this, and we couldn't have found this in the lab. And it's like, so I wonder, like, because I know that Jan LeCun was very kind of mad at Gary Marcus on Twitter about like this getting put offline, and I'm not going to give my personal opinion on that, but I think I wonder, like, I don't know, like, these examples of like badly generated papers, you can find that type of stuff in your own research lab. And it seems like if you write a paper like this, which I'm not trying to say that it's low effort, but I mean, most of what you're doing is the data part and the training part. And so also to interpret how well it's doing things. Clearly that should be a very important part of what you're talking about in the paper, is like cases where it's failing hard. Because if people can find it within 10 days, surely you could have spent a little bit more time like probing your model to kind of see what cases it's not working well in. And it seems that a lot of these people don't do that for some reason. Like they just are like, oh, here's our online test model that you can just use. And then they're like, oh, it produces wrong things. Well, thank you. It's like, okay, well, that's like the 10th model that does that. We're kind of aware of the fact that that's likely going to happen. So I don't understand why people don't do more research on what the failure cases are for these models before they put them out there. I don't know.
And before they put them out as applications, like is the thing, like if it's a research paper and you're like I think it's one thing to like, you have to talk about limitations in most like venues.
Right.
But like when you're creating a commercial application that is being used by millions of people, or even thousands of people, like it's just, you create so many problems when you aren't transparent about the limitations and like actively working to either remove them or limit them or make people aware of them, or this is a problem that's been with all technology on the internet for a long time. I mean, Europe has legislated against cookie tracking and stuff to try to prevent some of the stuff that people just weren't aware of, and all these problems that can be created by tracking. And it's just, it's a partially a cultural problem, I think, in research and technology.
But it started even like from images, like you can train my model CNN on ImageNet, but you go to internet and try to run it, it doesn't work. So So in the wild, like a lot of stuff doesn't work. I think they still should put it out.
As a commercial product?
No, it's not a product, it's like as a test.
I mean, Bing is a product,
Yeah, Bing is a product, but
right, but that's out.
Like
ChatGPT is also a product,
but-
they're charging people to use it.
Galactica wasn't a product.
No, I know, but I
Galactica,
mean,
I don't know.
I'm talking about more general.
Because like CNNs didn't work, like if you go to the wild, it doesn't work.
No, sure, but I mean, yeah, I understand about like putting it out there, but I think actually one of the things that may be happening is that people have in such a quick amount of time seen so much bad stuff from LLMs that the general public just doesn't believe them. Like you shut down the idea of using LLMs pretty quickly in society if you put these models out there. Because they're clearly wrong. Like it's even for normal people, it's clear to see that they're insanely bad still in a lot of ways.
It's like you're a consultant and there are many consultants that won't be better than LLM. Like, I'm just saying, for example, you have like consultants, right? Real people,
Mhm.
like you want to go them to some problem, but like they will tell you something like completely wrong too. I mean,
I'm not sure if this is a very false analogy, I think.
I just think like it's very,
That's that people lie sometimes or say wrong things, doesn't make it
I mean,
the case that you should make
wrong
these
stuff
models
too.
that just generate wrong knowledge all the time.
I think it's best if there is you, but if it's bad product, you just don't use it to solve.
I mean, but that's not the issue, obviously, it's people using it for bad things, it's not.
And people using it and not understanding what the problems are and then being affected by those
I mean,
problems.
victims use it for wrong things too.
But
Like,
people,
so-
yeah, oh yeah, people, I'm saying that's, but it's a fault, like, Eloy's right, like, just because people are also bad, doesn't mean that we should allow these models to be bad, like, of course, people are manipulative and people will lie and people will be in power and do crappy things, but we, as a research community are partially responsible for these models not becoming a part of an exacerbated problem of bias and, creating bad research and all of these things, like, yeah, when people create nukes, of course, people have been killing each other for years and ages, but you can't create a new way to like make a lot of people die. Like,
TV was never fixed, right? TV channels was never fixed.
I disagree. I think we should do our best to prevent.
I mean, I agree with you, you have to do, but like people won't do it. Like TV channels hasn't been like normal in any country.
Yeah, but that's again a false analogy because just because something else is bad is.
We should work our best to make sure that this is our field.
Yeah, I'm just saying that like it's a human problem.
Yeah, oh yeah,
No,
totally. But the
I
problem
agree
with
with
us is that this is where we're working. And so I feel partially responsible when the AI community at large is creating these bad things and we're not like taking some steps to like keep these people accountable who are in our community, right?
Right.
And are like, we're getting attached to what they are doing.
Yeah, I
I don't
think-
like that.
I could see-
I don't want to be a part of that.
I could see a scenario where in 10 years, people are so, like in 1 year, people are so anti, like the idea of AI, because they can see, like, a lot of people also think that their jobs are gonna be gone within the next year, and like, I don't know, I can see like, people don't like that stuff, so it's like a revolt against AI. I can see something like that happening with like how people are viewing AI currently, because it's going downhill very rapidly, like with Bing especially. People really, I've seen so many like general people just absolutely hate. If you read like the comments on like the news sites about Bing and stuff, they're like, let's ban this stuff now. Like, we don't want this at all.
It's a very weird phenomenon because like people who used to be excited about like everything science and tech have started to kind of drift towards being anti.
Yeah, and that's what I'm most annoyed about, is that this type of stuff, although it's already really cool, right? Like, I think the LLMs are really cool, and the fact that it sounds so natural is very interesting and insanely cool. And I think there is applications for that, but they're jumping the gun very hard. And I think that kind of is gonna make a huge wound in the AI community for a pretty long time to come, because now everybody's gonna like distrust everything, right? If this continues, this trend with like these super untrustable models that are saying that they're gonna kill humanity. I mean, it's like, like it doesn't really help if you have no idea what it is and people just tell you like, this is a robot that's talking to you, and the robot just says, I'm gonna kill you. Like, I don't know, the general public is not gonna be like, yeah, let's keep these models. Like, it's just kind of stupid.
Yeah, it's really just the like, who's gonna win? Is it gonna be the profit motive or is it gonna be like ethics and responsibility?
It's just stand-up
So
show,
far,
that's
it's
all,
always
like, you just have to react as a stand-up show.
I mean, I think actually even the making money motive, like if nobody wants to use your models, you're also not gonna be able to make any money from it. So I'm wondering if that's gonna change soon. Like seeing I don't know if it's backlash, but just the reactions to like these LLMs. I think ChatGPT actually was better than Bing for some reason.
ChatGPT has a lot of safeguards on it, it's part of it.
Yeah, but Bing too, and it even can like query the internet, but still.
I
It's,
think Nash equilibriums are kind of always worth bringing up in this context. Because like there's always like a competitive advantage of the person that uses AI even if they don't want to. And like for example, in writing papers, like what if you could like churn out like 10 times more papers by just letting ChatGPT like generate it, you correct it and then fill in like your results and stuff. Instead of having to like go to all these other papers and figure out like what you need to put there. And then suddenly like the whole community starts doing this and then you're like the purist, but so you only like publish like once a year because you're a purist and everybody else is using tools.
no, but I think as a tool, it can be pretty good. If you can verify, if you know what the correct thing is. So for example, if it's helping you write, it makes a lot of sense, right? If you're just, because you can check it, you check before you rewrite it a little bit, you can check it and like it's fine. But the issue with things like a search engine, like Bing, is that people often do look for things that they can't verify. Or they're gonna have to verify with something else, like they have to go to another search engine, which kind of defeats the purpose of doing the search engine in the first place. I think it can be very helpful if it helps you write papers, because you're gonna be checking the whole text, right, and making sure that it's what it's saying is correct. The issue is mostly when people don't know what's correct, and then they use it, and then it turns out to be wrong, right? I think that's mostly, I think LLMs are great if you can verify what it's saying is correct. So for example, helping you write, like I said, but every other thing not, and for some reason, it's now in search engines, which is exactly the place where people are doing things that they don't know is verifiably true.
It's being used for research and that's dangerous, I think. It creates a closed loop.
Yeah, exactly.
Hey, Alex, did you like actually read the paper on the theory of mind that came out of Lincoln?
Yeah, I didn't read it, I just found it's funny, that's all.
Yeah, I think that's kind of an interesting kind of thought because like as these things become better and better, like and do more and more of our work, then at some point you'd think that they're like our structure or the way we think would be at least equivalent, but in some way, I don't know.
I just still think of it as the way it's trained, which is to optimize like probability of sentences. And I think that's why the sentences sound really good. And that's why it's helpful for writing sentences, I think. But I also don't think it's anything more yet, which is fine. It's already really impressive. I don't know, like, to me, it seems kind of crazy because people want to over claim these things. I mean, they're already, if you think about 10 years ago, this is insanely cool progress, but it doesn't have to be, have consciousness or something yet. You know what I mean? Like it's this thing of like, sure, maybe in 50 years, but like, I'm just saying like, it feels like people want to just like, oh, well, it sounds so good now that we can just claim whatever about it because nobody knows what we're talking about, especially not like normal people that don't do AI research. Because everybody in the AI community is like, yeah, okay, it's definitely not, you know what I mean? But then everybody outside is like, oh, maybe, I don't know, it sounds like I'm talking to a person, and it's like, yeah.
Yeah, I mean, it definitely has weaknesses. If you ask it like mathematical topology questions, it'll start failing, stuff like that. So it's like, there's just like unexpected catastrophic errors.
Well, anything above like high school knowledge, essentially.
You could even not do like multiplication in some examples I've
Right.
seen, yeah.
If you ask it when Avatar came out, it says that it was in the past, so. It's like, it
That was
hasn't come out yet. And you're like, no, today is like today is like February 2013, and it came out in December. And it's like, no, it's not.
It's like trying to gaslight people, it is really.
No, it's not. I think it even said like you are in a time machine or something, and it's like can't be wrong or something.
Yeah, ridiculous.
We're at time. We didn't know it.
Maybe we are, maybe it's only the AI knows.
Time is always now. It is never not now.
Thank you, Alex, for that.
Yeah, exactly.
presentation.
Back to Alexis now.
Oh, yeah, crap.
Yeah, we're gonna start calling you